about chemistry.
You have a carrot penny. Not carrot. You have like something like the carrot penny.
Let's play a few rounds of predict the products. Ding, 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 ding. After those few rounds, I can't find the Wi-Fi. I think Mom took the band. So, predict the products. Ready?
It's actually useful to write it there because then you can
Here it goes. But the problem is I can't erase, so I have to make sure you don't make mistakes.
Oh no! Oh no! Make mistakes! Don't make mistakes!
Oh.
See, look at this. 0 equals. Not a number. 0 equals 0 equals 0. Done.
Predict the products. Okay, tell me what the products of this reaction will be.
We need a periodic table.
Oh, okay, okay.
I think I know what that is.
Reach your things! Dad!
Take one and pass it around. Take one and pass it around.
I hate papers.
You hate them? What?
I want it.
There you go.
I want to.
There you go, couch friends.
Wait, can I see a piece of paper?
What?
Oh,
Piece of paper.
Oh, I figured out. I figured it out. I figured out the product.
You figured out the products, huh?
Yeah, I did. I figured out the product.
Okay. So,
The products are
products are what?
sodium nitrate and cesium phosphate.
Very good. Very good. You guys agree with that, couchers?
And
Yeah.
if you guys were listening.
How about down here on the rug? Do you agree? Okay. So then, are either of those products insoluble? Yeah, because if they're both soluble, we decided last week that what? They don't interact and it's no reaction.
One of them is not soluble. Cesium phosphate is. Wait, no, it is. They're both soluble. Cesium's in the alkaline. Yeah, they're both soluble. It's a group 1A.
Did you get that, little wickers?
Yeah,
They're both soluble. So what did we put down here?
shiny bar.
Nothing.
NR. Yes, all are aqueous. No reaction. Because just combining ions in the same container doesn't a chemistry reaction make. Right? To be a chemistry reaction, a chemical reaction, what has to happen?
It needs to be solid.
We need to have a change in how
Because when it goes
things
into
are
water, it just
interact.
splits into its ions.
ions. That's
So
right.
it'd just be, so then if you tried to mix them, there'd just be a sodium ion. Wait, that would suck.
If they're already happy,
Yeah.
oh, they can be happier. That's a big secret of the universe. Everybody thinks they're happy until they find something new.
But they're just gonna have
Same amount of what?
same amount, but they'll be more stable.
Same amount of what?
He means they'll still
Oh,
have,
right,
they'll
right.
still
So
be
here's
noble-
why.
noble-ish,
Here's
but
why.
they'll be more stable.
Here's an example why, okay? Here's a compound called CH4. All right? CH4.
Carbon, hydrogen?
It's called, actually, it's an organic compound. It has a different naming system. It's called methane.
Tommy.
Oh, yeah, these guys.
Tommy.
CH4. All right? This compound formed by what? How do you think this compound formed? Tell me their story.
A carbon said, oh no, I need 4 electrons. And hydrogen said, I want 1 more. And so they met together and started sharing electrons.
All right. They got into
And then
a
he's
large
like,
group.
hey, I can get my 2 brothers, my cousin.
Yeah.
And then we can share electrons. Yay.
Does everybody agree?
Yeah.
That's how that compound formed. All right. Now, if you combine CH4 with oxygen gas, all right. Now, how do these two oxygens come together? What was their story?
They needed needed 2 more electrons, and so
Yes.
they
They both needed 2 electrons. Do you know how we can tell that they needed 2 electrons? Look where oxygen is on the periodic table. Point to it with your
want to be
finger.
like neon.
And then if we move over 2 electrons, the fluorine and the neon, we find a noble gas. So that shows us that oxygen wants to have 2 more electrons.
So he called his buddy, and then they started sharing electrons.
Yeah, because that other oxygen also wanted 2 more electrons.
So you have to have 10 on
Yeah,
They
you
don't
want to have,
but they
you
want
want to either have, what are the numbers? You want to have 2,
2,
10,
10, 18,
18.
36, 54,
Does that make sense?
86.
Those are the magic numbers, right down here, right? If you have that many number of electrons on you, then you increase your stability. Hey, 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 hey. Try to use your ears a little bit more, okay? All right, so here's what happens when CH4 combines with O2. 2 molecules which, again, have found ways to share electrons. What happens is they rearrange themselves. And carbon goes with 2 oxygens, and each oxygen goes with 2 hydrogens. Like this. They rearrange themselves.
Can you draw it with like C's, O's, and H's? Because I'm not sure.
3 oxygen?
Oh, you mean, how do you balance this equation?
How is there 2 oxygens in the car? 2 oxygen.
No,
Yeah,
because that
so
means
let's balance the equation.
it
Let's
says-
balance the
what
equation.
it means.
How many carbons do we need on, let's see, carbons look like they're balanced, right?
Yeah.
Oxygens, they're not balanced, right? We need 2 more oxygen, right? 2 more oxygen atoms.
Is that
Hold on just a second. We had a question about balancing, so we have to balance the equation. So if I put a 2 there, that would fix oxygens. But then I would need a 2 here to fix hydrogens, right? So if I put a 2 here, I'd need a 3 there. So I think we'll be okay if I put a 2 here, because that'll give us 4 hydrogens, right? Everybody see that? The top here has 4 hydrogens, at the bottom has 4 hydrogens.
Why does the bottom have 4?
1, 2, 3, 4, 5, 6. So if I put a 3 there,
oxygens?
you know, while I was doing hydrogens,
But
And oxygen in conjunction?
4, but then you add 4. It says the top has 4.
on the top it has 4, CH4, and on the bottom it has 2 of these H2Os, so that's 4 hydrogens.
Oh,
So now it's a balanced equation.
it's not?
It's not?
3
Oh, 1, 2,
oxygens.
3, 4, 5, 6,
No,
3,
because that
5,
2
6.
goes to the H.
This 2 here?
Yeah.
No, it goes, oh, H2, yeah, that's right. Oh, yeah, you're right. So we got,
It's only 4.
so we got 1, 2, 3, 4. Wait, 1, 2, 3, 4. Yeah, so this is just a 2. There we go.
There you go.
Okay?
so that means that, okay.
So that's how the party actually occurs. One of these met 2 of these, and they formed 1 of these and 2 of these, right? Now, why did it occur? Why did chemistry occur like this?
I have no idea.
Because carbon is more stable with oxygen than it is with hydrogen. And this oxygen here is more stable with hydrogen
Why
than it
is
is by itself.
why is oxygen more stable? Something.
All right, because if 2 oxygens are sharing electrons together, it stabilizes them a little bit. However, when they start sharing with carbon, carbon likes to give up electrons, share electrons, more than oxygen does. All right, because not all atoms like to share electrons the same amount. Okay? Now, that was all a side question that we answered. It's an important thing to understand.
So it'd be
That-
C with 2 O's, and to each other it'd be 2 hydrogens.
Wait, C with 2 O's, what do you mean? Oh, right, yes. So let's draw what these molecules look like. Carbon, double bond to an oxygen, that's our carbon dioxide. That's what it looks like. And then oxygen binding to 2 hydrogens.
And so that happens to each oxygen. That's how it works.
All right, so the point of
Each
this little
oxygen
side
has-
story is that atoms can stabilize themselves better and better in different ways, and that's what drives chemical reactions to occur. Does that make sense? All right, Now, the new component that I wanted to show you today was this. Let's first of all play one quick little half round again of predict the products. All right. So here's the chemical reaction that we're going to predict the products of really quick. Let's look at this reaction. Talk to your neighbor, see if you can predict the products.
I don't have a name.
Oh, I think I found it. I found it.
Talk to your neighbor. We want to make sure your neighbor knows. Predict the products, gentlemen and gentlewomen. Okay, so what are they? Wicker boys. What's the products?
What am I thinking?
Couchers or rug people? Any product predictions?
I can predict.
What do you think? What will the products be for this one? Why don't you whisper in his ear so he knows?
It is
Sodium goes with what?
nitrate.
The NO3 here, is that right?
Nitrate, yeah.
All right, they switch places, right? NaNO3 and
Gold.
this is silver, Ag.
Silver chloride.
AgCl. Are any of these solid, insoluble?
Yes, Ag. Silver chloride.
Okay, how do we know that?
Because group 7 makes it soluble unless it has silver lead.
What rule is that on our solubility rule?
That is
5.
4.
No, 5.
Rule 5?
Yeah.
Okay.
No,
Three?
I don't think it's rule 5.
Where's rule 2?
Oh, it's rule 3.
3.
All chlorides, bromides, and iodides, salts containing chlorine, bromide, or iodide are soluble except when combined with
Okay.
silver.
Now I'm going to show you a different kind of reaction. So this is a standard reaction that we've been championing.
What happens with those? That's how there's a reaction.
What's that? What
There is a
happens?
reaction with those.
It's a precipitate reaction, right? Now here's another reaction. Another reaction. Let's see. There we go.
I like to move it. I like to move it.
Okay, here's a chemical reaction.
Oh, this is strontium plus chlorine plus 2 chlorine
Yeah.
equals strontium chlorine.
Strontium
Strontium chloride.
Strontium chloride. Now we want to look at the difference between these two kinds of reactions. Okay? In this one here,
That's combining.
what kinds of compounds are these?
Those are ionic.
They're ionic compounds. How can we tell that they're ionic compounds?
Because there's a metal element on there.
There's a
In
metal
that,
element on
it
there.
looks like they're combining ions.
In the products
The
here,
other one.
they're both what kind of compounds?
Ionic.
Ionic compounds. What's the ionic charge on sodium in this
Sodium
compound?
plus. Well, once you add it together, then it's 0. But
No, yes, but just the sodium ion itself, what's the charge on it?
plus.
It's a plus charge because it had how many electrons?
11.
11. It wants how many?
Divided
It wants to have 10, so it's going to get rid of 1, and that's going to give it a positive charge. In the products, what's the charge on the sodium ion?
plus. It doesn't change.
It doesn't change. All of these ions, in fact,
It will change.
have the same charge. Do you agree, Wicker boys?
Yeah.
You sure?
Yeah.
All the ions are changing.
Now, in this case
In
here,
that, they're adding ions.
in this
together.
case here, we have something different going on, right?
They're adding together ions.
What's the charge on the strontium here?
Plus.
Normal.
Yeah, there's no charge, right?
Right.
It's just a strontium atom. Can you guys tell me how many electrons strontium has? Can you find that on the periodic table? How many electrons does strontium have? Wicker boys, how many electrons does strontium have? 38. All right. Can you find it, Wicker boys? Look at the periodic table. Find strontium. How about chlorine? How many electrons do these chlorine atoms have?
34 if you count both. Both together, 34.
All right, individually though. Individually,
Individual
17.
17, together 34.
individually they have 17. In this compound, how many electrons does strontium have?
38, no, not 38 anymore. Because it gave 2 away.
How many electrons does strontium have in this compound?
It has 36.
It has 36, right? Because it did what to form this compound?
Because it lost 2 and gave 1 to each chloride.
That's right. It lost 2 electrons.
Giving 2 chloride.
This reaction here is
It's ion.
an electron transfer reaction. Do you see that?
Yeah, they're.
Electrons are
I'll give you
transferred.
this,
Yes.
because I don't want the. I
This
need
reaction
to
here is what? What kind of a reaction is this one?
Ion switch.
This is an ion switch electron. We call this a double replacement.
Yeah, because I don't know the right name, but
Yeah.
basically it's just switching.
So that's what we want to begin to explore. That's what we want to begin to explore. How there's multiple kinds of reactions. This is a double replacement where ions are trading places. And this one is an electron transfer where electrons actually change. Oh no, that's the garbage man. Ah,
It's A15.
he's leaving. All right, see you later.
It's just
Don't forget